All right. Good afternoon, everyone. So, in my last video, I kind of demonstrate how you can implement Stack, which is the MongoDB Express, React, and Node.js stack on AWS and EC2 instance using a self-hosting MongoDB on the same instance. But today, I'm taking it a bit on the Angular side, which is the main stack, which stands for MongoDB, Express, AngularJS, and Node.js. So I've actually I've actually you know launched a similar application. It's currently running on my my current instance. So in this video, I'm going to take you through step by step how I was able to implement this on AWS. Let me just do a bit of a demo to see how the application works. I think I have some data here. So let me see. Let's add this. Uh, which is a pragmatic programmer. I don't really know what the name of the book is. All right, so this is the number. You can see. I can add it here. Okay, I think we missed the line. Then the author, right? The author. Then the number of pages. Let's paste them there. Let's say add book created successfully. Okay, then you can see the book down here, right? Which means that has been pushed to the back end, and we can see it here. If you look through my instance, based on the feedback I got, I have to increase the font. So let's get into the instance, which is the instance that is currently running. Right, it's taking a bit of time. Right, it's taking a bit of time. Um, I noticed that at some point the SSH might refuse to connect, and I think I find a workaround around that. I learned is kind of an issue from Mac OS kind of thing. So let me cancel this first. Clear this. Let me type this sample. Right. Then I can do. I think I know this. Can do sudo cmod sample. Oh, sorry, that was the wrong command. I need to put the permission I'm trying to apply. Then I think now I should be able to connect. Confirm if my IP address is still valid, because I set it to only connect to my IP address. So let me just check this first, just to compare. Just to compare. Still the same. So I don't think there's an error problem around that. Let's save. Let's see which one has it changed. Okay. So let's check again. Alright, I think apologies for that break in transmission. So I just wanted to get uh, to the instance on AWS. Alright, I think we are inside the instance. Okay, so if I do p2 p2 log, you can see that server is running. Just do a bit of right, so can do let me call it to the browser. Right, the browser is running, so I kind of restart the so I can do repeat to list. See that my application is live. So let me edit this and let's start from scratch. So what I'm going to do is I'm going to come here, I'm going to close this, I'm going to come here, I'm going to stop this, right, and done. I'm going to terminate this instance. So while that is doing what it's doing, so let's create a new instance, and we'll call this instance main stack. I just call it, since it's book register app, which is the app we are trying to run on that instance. Select your operating system. Select the instance. So I'm just going to leave the default apart from what I've picked here. I'm going to select my existing people, and I'm going to select my existing security group. After this setup, I'm going to show you how I set up my security group for this project. We are maintaining our port 5000 for the backend. We will not be bothered about what the front end port will be because we'll be serving the front end through the backend, so it's not really a problem to be bothered about that. So let me just show you how my typical security group setting looks like, so I can explain. So my SSH is on port 22, and I'm only allowing traffic into that via my personal IP address. So if somebody tries to access my instance from outside my current IP, it will be blocked. Then the normal browser, which is on port 80, is accessible to everybody, so traffic can come from anywhere in the world. Then my what do you call it? This is my MongoDB. For security reasons, I'll just change this to my IP address also. Alright. Then port 5000, open to the internet and the likes. So I'm going to do this. I'm going to save this, right? Save this rule. Then we're going to go back to the instance. Right. So I've actually documented my entire approach in my GitHub repo, which will be linked in the description of this video. And I'm going to go through the entire step-by-step instruction with you guys so that you can see how the entire thing works. So my instance is running, so I select it, as you can see, then I click on connect, then I copy this, I'll come back to my again. So I come back to my terminal. You can see in my terminal, I already have my key pair. I'm inside a folder that has my key pair. So based on that, I can just run this command based on what I copied on AWS console and press enter. If everything goes well, I should be in, which I am. Now, so let's go back to the GitHub documentation of how I was able to implement this. Now we have prerequisite, installing MongoDB, configuring your MongoDB, installing Node.js, installing the P2, which is the process manager that ensures that your application keeps running even when you are not actively logged into the console. So far your instance is running on AWS, your application will keep running once you start it. And the interesting part of this process manager is if for any reason your application run into an error and your application crash, the P2 manager, which is the process manager, will automatically relaunch your application and keep it running perpetually. And for maybe for one reason or the other, you probably reboot your AWS instance, or you shut it down, you turn it back on. Once your instance come back to life, either from rebooting or it's coming from a whole code start, what the P2 will do is it will automatically restart your application, launch your application for you, and everything will just run behind the scene. So once launched, everything should work perfectly. Then, like I always said in my last video, I said DevOps action or DevOps activity is less concerned with software development process. We are less concerned with if it's Nginx, if it's React, if it's Java, if it's Spring Boot, if it's Ruby on Rails. We are less concerned with the underlying software architecture per se, like how was the software built? Should I start learning how to code in Angular? Should I start learning how to code in React? We are less concerned with that. What we are interested in how to deploy a package software. A software has been built by a team of developers and the likes, and the software is ready to be deployed on a server, either for the final consumers or probably for the testing, the what we call the testing environment for the QA team to test the application to ensure the application is running as intended based on the product required documentation. So your role as a DevOps basically is for you to take that fully developed software or software package and deploy it on a server. And interestingly, you might probably want to deploy on a local server for people that run maybe a hybrid system where they have a local server, even though they are using cloud and local server simultaneously. Your focus as a DevOps is to deploy um, a piece of software and ensure that all the related infrastructure are available to power the solution. So I'll be taking you through a typical DevOps process in deploying a main stack application, which is a MongoDB self-hosted application on your instance, your Node Express, your Angular JS, and your Node. Now, so the application, so to simulate this real life process, we have actually created a sample application, a sample main application for you on GitHub for us to be able to simulate it, which is this. This is a sample. In my last video, I used a sample to do app, which is a main stack, which is a MongoDB Expert React, which is a React application being powered by a backend system running on Express.js. So for this particular tutorial or video, we'll be looking on how we can launch a book register application written in AngularJS and being backed up by a backend system running on Express.js. So back to the DevOps activities for this main stack. So the first thing, as you can see, how I launched an instance on AWS, which is the prerequisite. You have to launch an instance on AWS running Ubuntu, basic knowledge of Linux based on the different commands we'll be running. But in this tutorial, I'm going to show you all the various commands. Then when we are done with setting up the infrastructure, then we will launch our main stack on the said infrastructure. Almost 80% of your work basically is to set up the infrastructure that will be used to power or to support your application running on a server or on the cloud. Now, I recently discovered that I don't know if this is peculiar to Mac system, but what I discovered is that um, I my system wasn't really responding to the SSH command for me to be able to launch it remotely into my instance. And while I was digging around, I discovered that there's some peculiarity about some metadata being attached to your key pair. Then I was asked to run some of these commands to be able to get it running again. So in case you have a similar problem, you might probably want to use that to troubleshoot your issue. So the first on our list is for us to install a MongoDB instance on top of our AWS, which means that our MongoDB database will be running on our AWS EC2 instance. So to do that, I'm going to copy this code, which is going to import the public key for the MongoDB package, which means so I'm going to go back to my terminal, I paste it, I press enter. Then I'll go back to the next instruction, as you can see, which is create a MongoDB source list file. I'm going to do that by copying this. Um, Bear in mind, this code or these commands are not something I invented. I just went to the MongoDB community version documentation to be able to get this code, and you can kind of check it. As the last time I checked, they have a good documentation for how to install MongoDB on Ubuntu. Now, the next thing I want to do is to update my package manager, as you can see, or my package list on the OS, which is currently ongoing. Then the next step is to install the MongoDB package itself, as you can see. So I can clear my screen, then installing. Then when you are done with the installing, the next thing you want to do is to start the MongoDB service. The fact that we have installed it, just like we have in Nginx, when you install an Nginx, automatically the service starts by itself without you needing to start it. But in the case of MongoDB, you need to start the MongoDB service, right, which is this. Now, the fact that you have started the MongoDB doesn't mean that it will continue to run when you power down and you power, or maybe you reboot your system. To ensure that your MongoDB is always running, when you probably power down your system and relaunch your instance for one reason, so far your instance is not destroyed, you want your MongoDB to always run, so that when your application is running based on the P2 process manager we have set up, you will have a MongoDB instance to communicate with. To do that, we are going to run the enable command, which is this, which will enable this at the system level, so that once your system boots up, it will automatically start the MongoDB service, as you can see. Um, Now let's move down to, so that has been done. The MongoDB has been what I call is installed and enabled, and you can check the status of your MongoDB by running this command. As you can see, it's running, it's active, and it is enabled for system, system booting, system reload, and stuff like that. So basically, what the enabled command does is that it ensures that your MongoDB is added to your startup application, which means anytime your instance startup, MongoDB will be part of the essential services that your system will automatically start by itself. So let's move on to the next part. We have tested the status of our MongoDB and everything is running perfectly. Now, for security reasons, when your MongoDB install is basically allow traffic from the local machine, that is the machine on which the MongoDB is installed, which means you won't have access to be able to access your MongoDB remotely. Now, to be able to allow your MongoDB to allow for remote access, you have to log in into the MongoDB configuration and change the bind IP to 0000, which is allow all IP. But for my sake, since my application will be running directly on the same machine, my MongoDB will be running, I won't need to touch this configuration because I won't need to be accessing my database remotely. So which means we are going to skip this, but I actually added this for the case of people who want to either want to test their application locally and want to take advantage of the MongoDB instance running on the EC2. Now, let's move down to securing how do we secure our database to ensure that only authenticated users can have access to our database, which is just an extra layer of security. Now, if you launch into your MongoDB shell, as you can see, I can log into my MongoDB shell, right? And what I'm going to do is I'm going to change to the admin database. Now, we need to create an admin user that we are going to be using to log in and perform different functions on our database. So I'm going to copy this code, as you can see, and I'm going to paste it there. It shows that we have created an admin user. For us to test that what we have done is actually working, as you can see, now I need to first enable the authorization configuration for us to be able to properly test that what we have set up is working as intended. So I'm going to scroll down to the security portion. I was talking about the binding IP the other time. So if I probably want to allow access remotely, I'm going to change this into 0, 0, 0, and 0. But for now, what you have there is the local host. As you can see, is being bound to the local. So I'm going to come to the security section and I'm going to uncomment this. Then I'm going to add the authorization declaration here. So I'm going to paste that over here. So I think it's a YAML file. So 2. Then I'm going to save. Yeah, that is being saved. Now, for it to take effect, I need to restart my MongoDB server. So which I'm going to do systemctl restart MongoD, right, which has been done. Now, so let's test if everything is working. If you remember when we were setting it up, we set a password of password capital P.1. You can set any password that you want for your root user, but make sure that you keep the password as secure as possible, that non-authorized user does not have access to your admin user password, which can be detrimental or can lead to a serious data leakage. So for us to check if everything is working, I will run this command, right? Then I will be asked to enter my password, which is right. Voila. You can see that now. If I try to let me show you the importance of what I did. Let's assume if you remember initially we do Mongo shell to enter the shell when we initially install. If I do this now, right, you enter as as the admin. Um, right. So, but you are not. So if I do this, Mongo sh plus u root. So if I want to come in as a root user, you can also do this too, which allow you to come in as a root user, right? Um, as you can see, authentication fails. Let me try that again. Now I can come in as a root user. Now let's exit this. Ideally, I'm not expecting this to work, right? But it's working. So let me try to restart. Let me try to restart my. Let me try to restart my MongoDB to be sure that the new setting has taken right. But let me confirm the configuration again to be sure that I did the configuration properly. Okay, I think everything is fine. So let me close this. So I'm not expecting to be able to log in, but funny enough, is logging in, which is kind of weird if you ask me anyway. But let me do a bit of search. So apparently, despite that you have actually enabled the security authorization command on your configuration, you will still be able to go into your database, connect to it, but you won't be able to perform any kind of operation. And let me just show you an example. Now, normally, you should be able, normally when you log in, I will probably want to create this database. Now, if you see, so let's see this. Apologies for that. So normally I'm supposed to, use this. Then I'm supposed to copy this to create this user inside this database. Remember, I did not authenticate. So if I create enter, you can see Mongo server error unauthorized. So because I don't have the right authorization, I will not be able to do this. So let's exit, which shows that our configuration is actually working fine. So let's exit. Let me go back and copy the right command, providing the right authorization. Now, so if I come back and I do this, right, and I enter my password, one, right, I'm here, then I can change back to, uh, let's jump back to this, so that I can perform the operation against that database. Then let me just copy this again. Right, so that has been created, so I can exit. Now, to test that what the new user we have created is working fine, right? I can copy this, which is if I want to connect using the connection string. So, which we are going to use, which is what is being used in the app per se. So if I do this Mongo share and I type this, you can see that I'm connected directly to this database. We are not, I'm not connected to the test database based on what you said saw earlier, but I'm connected directly to this particular sample book register app. So that shows our configuration is working fine. Now, so let's move on. Let's move on. Now, this has been done, as you can see, which gave us the same. So the next thing is that we want to install our node. To install your node, you just paste the code to get the node packages. Then, so what I copied will get the node package and instantly to install because I copied the two commands together, right? To be sure, so if you can see, the two commands were copied together. Let me see. Okay, you can see I copied the two commands together. So it happens sometimes. So, but Linus is able to know that it's two separate commands. So to be sure that this works, I can check npm version 2. Everything is fine. Then node, that's just node. I'm done with everything. Now we need to install the process manager, which will be responsible for running our application perpetually. So we can do that by doing so. We are going to install it globally, which means that we are not installing it, we are installing it directly as part of the underlying Ubuntu, node packages, not just for the application. Now, okay, it's telling us that we need to update our node package, npm package rather. So it's going to be installed globally. So I need to provide the sudo to give it administrative or root access because it's going to install and create a lot of stuff in the background. So let's clear this. At this junction, I think we are almost done. Now, for our application to be able to run, normally when you run your application, it will be running on port 500. But we don't want our user to be typing port 500. Ideally, you probably have maybe a domain name that you have bought, and you want people to be able to go to that domain name to see your application running. Um, so for us to do that, we are going to create what we call a proxy server using Nginx, which means that when people visit our domain name or visit our the public IP address for our instance, right? Uh, which is going to hit the root folder of our Nginx project folder, but Nginx will now redirect that traffic to the application port 500, which is the backend that is running, and the backend will now serve back the front end content to the Nginx, which the user will be able to see, which means it's more like, the Nginx is more like a middleman that helps to communicate our users, intention to our application server. You know, our web server is Nginx, but our application is running on application server using Node.js environment. So for us to achieve that, we are going to install our Nginx. So let's first update our packages. If you see, there are some command that will use apt-get or and some are just do apt. Actually, they are basically the same thing. I can just change this to let me see. get, and it will work as intended. So like my people will always say, nothing spoil. Now, so let's install our Nginx web server, which we are going to provision as the reverse, as a proxy server that will communicate with our application server. Now, that has been done. So we need to create a custom Nginx configuration where we are going to tell Nginx how it's going to handle traffic from the public. So I'm going to do this. I'm going to copy. So if you check my documentation, I've already defined what we want to copy there. So let's copy, then I will explain what the whole plenty stuff is all about. So in this code, what you need to pay attention to basically is this: the listening port, which is our default web port, which is HTTP port, which is 80. Then server name. This is supposed to be your domain name. If you have a domain name, this is where you're going to put it. But given the fact that I don't have a domain name for this application, so I'm going to put an underscore telling Nginx that I don't have a domain name. Now, in the location block, you see that I've actually passed a proxy. So what I'm telling um, Nginx is that whenever a user visits the base URL, right, that request or that traffic should be passed back to the application server running on port 500. The other uh, configuration are just the basic configuration of Nginx. So we are going to save. Yes. Now we need to activate our new configuration. And to do that, I'm going to copy this to activate that, paste it here. Then I'm going to test if what I've activated is correct or if my configuration has some errors. Do that by clicking this. As you can see, test successful, which means my new configuration is fine. But for Nginx to be able to recognize this new configuration, we need to deactivate the default configuration that comes with Nginx. Right, that has been done. So we need to restart our Nginx server, web server rather. Done. So that has been done, right? So next, which is the final hand, is how to deploy the main stack application on our server. Now, for Angular, Angular has what we call a console line, um, what do you call it, interaction or command, which you can use because Nginx is kind of Angular is kind of different from React, where you can just use your package JSON, the word directly with your npm package manager and stuff like that. But for Angular, it has its own command line console package that it uses to run servers and stuff like that. So for us to be able to have access to that, we need to install the Angular CLI on our server. You can see we still have the -g command, which means that we are installing this globally on our system so that it is accessible by any application running on our system. So while waiting for that um, okay, done. Now what we need to do is we need to clone the repo. Like I said, the repo we are working with is this. Let me see. Let me see. The repo we are working with is basically this. Sorry, this. This is the repo we are working with. And if you go back to the repo, you can simply just copy the repo command, the repo link, and come back to your line, your terminal, and do git clone. Then you can paste this. it will automatically, just download the repo. Now, you can do cd into the repo folder. Then I want to go to the client side first. In the client side, I want to run package I, which means I want to install the node packages defined in the package.json file. And when that is done, I also want to run a command which says npm run build to build the application into HTML, CSS, and JavaScript file that the uh, backend server, which is the Express, will be able to serve, which is more like we are generating the static file. Blah 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 is asking for auto completion. I'm not interested in auto completion, and I'm not interested in telling Google what I am doing on this server. So we'll give it some time while it does its own thing to generate the static file that we will be needing, that we'll be able to serve from our backend. Now that has been done, I have to go back to the backend folder. Then I'm going to do the same npm I, but we are not building anything here because the backend server it doesn't generate any static file. So now this has been done. The next thing I want to do is to create is for us to generate our environment variable file, which is the .env file. I'm going to show you. Let's just go back to our documentation. Let me just use this. Right. So let's go there. All right, so this has been done. We have done this, which is the client front end. We are in the back end. We have, installed the packages. So we need to create the Nginx file, which we are going to use by using the nano command. Then, if you remember, we are going to copy this. If you remember this code, this is how we communicate with our database, which is similar to, I are saying, no, run this on port 500 and we are running a production environment. So so you can paste this here, then click on save, yes, and enter. So once that has been done, the final step basically is to start our PM2 process to be able to run our backend. Like I said, ensure that you are inside the folder that has the .env file so that your P2 will be able to read your environment variable and use it with running your index.js. So where I created a file is inside the backend, so I can easily run the command here inside the backend folder. So now my application is currently running, and I can test that out to know that everything is working fine by going straight back, by going into by navigating to my my Insta public IP address. If everything works fine, we should have our application up and running. Voila, as you can see, I have my application up and running. But we are not done. Based on what we have done so far, if I shut down, if I shut down my instance for any reason, let's go back. So let's assume I wanted to stop my instance, for example, or let's just say, okay, I'm not stopping, I just want to reboot my instance, for example, right? Let's wait for it to fully reboot. Now, because I've rebooted my instance, you can see that I've been logged out of my terminal. So I can log in back into my terminal. So while waiting for that, why is it refusing to connect? That's strange. Okay, now I'm in. Now if I do p2 list, right, you can see that nothing is actually running. Nothing is running currently on my server, which means that because I turned on or rebooted the server, everything has gone gaga, which means if I try to do this, it will have a 502 back gateway because nothing is running. They can't, NGS transfer the traffic to the set port, but nothing is running on the set port. Now, so which brings us back to the next part. So I need to, restart, relaunched this. Remember, I said you have to run that command while you are inside your backend folder. So I have to go back into my backend folder and run the command. Now it's working. Now the next, for us to ensure that this run perpetually, right, I have to run this startup command, right? Now see, I run this startup command, then you see this code, you are asked to copy this command, then paste it back, then copy where you have this p2 save, then voila, everything is set up. So if I do p2 list, I should still see my application running. Now if I go back to my instance and let's do another reboot, I'm rebooting my server to know that that has happened, right? I will go back to this. You can see I'll also be logged out. So I will do, let's connect back. So while that is working, let's go back and refresh our browser and see if we can communicate with our backend. It's working fine. You see, the system launched itself, and if you come back to this, I do p2 list, you can see my application is online. So my friend and subscriber, this is how you deploy a main stack application on an AWS EC2 instance. Thank you, and looking forward to more engagements. Subscribe and like my video so that I can always do these similar videos on different stack in the future. Thank you, and I appreciate your support.